Hello everyone. In this presentation we were discussing about the metal casting, and in this video we are going to discuss about the number of numerical problems based on the gating system. Okay, few of them has been asked previously in the gate examination, and one of the numerical problems that I have added for this. Okay, so let's discuss it one by one. First is determine time required to fill the entire mold cavity along with riser. So for this problem, this figure is given to you. So the total height, that is pouring basin plus sprue, is 20 centimeter up to the parting line. Okay, and this is a gate, and the cross sectional area of this gate is given to you, that is 5 centimeters square. After that there is a mold cavity. So this mold cavity is of total 30 centimeter height, but for the 25 centimeter the cross sectional area is 30 by 30, and for the remaining 5 centimeter the cross sectional area, basically that is a riser, so the diameter is given to you, that is 10 centimeter. Okay, so what we have to do is in this problem is we have to find out the time required to fill this entire mold cavity along with riser. Okay, so what the concept we have to use is we have studied about the parting gate. Okay, so what is the concept of parting gate is whatever mold cavity below the parting line, we have to fill that mold cavity with the help of the top or vertical gate, and whatever the mold cavity that is above this parting line, we have to fill that mold cavity with the help of the bottom gate. So now what I am doing is I am dividing this whole mold cavity into three sections, that is A section, B section, and the C section, that is riser. Okay, so A section we are filling with the top gate, B and C we are filling with the bottom gate. Okay, so let's start. These are the data that is given to you, that is HT 20 centimeter, AM that is 30 by 30 centimeter square. Height for this A section, mold A section, that is 10 centimeter. For this B section is 15, and for this C section is 5. Diameter of the riser is 10 centimeter. Okay, first A section we are filling using top gate. Okay, so this is the time required to fill this using top gate. Okay, so the VM, that is volume of the mold cavity, upon AG, that is cross sectional area of the gate, into root square 2G HT. HT is total height, okay, of the sprue and pouring basin. Okay, so the everything is given to you, you just have to put the values, that is 30 by 30, that is cross sectional area of the mold, and 10 centimeter height, that is the volume of this mold cavity, upon 5, that is cross sectional area of this gate, into root square 2G. Here everything we are writing in centimeter. So this G, that is 9 meter per second square, we also converting it into the centimeter per second square, so that is 981. Okay, so when we will put all these values and calculate, we'll get this value as 9.09 second. Okay, so time required to fill this A section is 9.09 second. Okay, next we are going to fill the B section. Okay, so from the B section we are starting from the parting line, and we are filling it up to the 15 centimeter. Okay, so that formula for the bottom gate, we are using this dt is equals to am by ag into dh upon root square 2g into ht minus h. Okay, ht is the total height, and h is the height that is varying from the parting line. Okay, when we are filling above the parting line, so this height is varying from 0 to 15 centimeter. Okay, so when we'll integrate it from both the side, then from here it's a very simple integration, that is when it will reach above or in the numerator, that is ht minus h root square minus 1 by 2, sorry, raised to minus 1 by 2. So it's a simple integration of x to the power n into dx, so that is x to the power n plus 1 upon n plus 1. From that we can calculate this value easily. So this will be 2g 2am upon ag into root square 2g into root square ht minus root square ht minus hm. Okay, when we will put these values, so now what we are doing is we are putting these ht value and hm value. So the total height of this ht is 20 centimeter and hm is 15 centimeter. So when you will put this value, we will get this values. Okay, so this is TB, that is TBB, that is time required to fill the B section using bottom gate. So that is 18.1735 centimeter. Okay, fine. Next is we are filling the riser by the bottom gate. So now height is we are calculating from the parting line. So datum label is parting line, but this height is varying from 15 centimeter to plus 5, that is 20 centimeter. Okay, so this is only the difference. Okay, so when you will integrate it, we have to put these values. Now one more difference is that AM, that is mold cross section, mold area. Now here we are not considered as 30 by 30 because the area is here is pi by 4 d square. Okay, so that is pi by 4 10 square. Okay, everything in same. Also G is converting into the centimeter per second square, and everything all the values we are putting over here. So TBC, that is time required to fill the C portion using bottom gate. So that is equals to 1.5858 seconds. So these are the timing that is individually filled this portions A, B, C respectively, and now the total time will be equals to the summation of all these three. Okay, so that will be equals to 9.09 plus 18.1735 plus 1.5858. So that will be equals to 28.8493 seconds. Okay, so this is the total time required to fill the entire mold cavity along with the riser. Okay, next problem is asked in the gate 2005. So let's start. A mold has a down sprue. I am also using one of the figure for all the problems that has been asked. Okay, so I am using this figure because through this you can understand it very easily, that what is sprue and what is the height of that, what are the cross sectional area that is given to you. Okay, so that will be simple in calculation. Okay, so the mold has a down sprue whose length is 20 centimeter and the cross sectional area. So this height is 20 centimeter. Okay, and the cross sectional area at the base of the down sprue is 1 centimeter square. So this is the gate we are using. So this is basically the top gate, and the area of this gate is given to you, that is 1 centimeter square. Okay, the down sprue feeds a horizontal runner. Runner is also given, but as we have already discussed that when we are using a top gate, then there is no meaning of runner because it's just a horizontal passage. Okay, that is through the runner leading into the mold cavity of 1000 centimeter cube. Okay, so this is the mold cavity, and the volume of this is 1000 cc. The total time required to fill the mold cavity will be, okay, so that we have to find out. So top gate we have already discussed, so we have to calculate the time, that is TP is equals to these are the data that is given to you, HS, AS and VM. Okay, so this is the formula for that, that is TP is equals to VM, that is volume of the mold cavity, upon AG, that is gate of cross section area of the gate, into root 2G HT. Generally we are using here is HT, that is total height, that is HP plus HS. So that is a pouring basin height plus sprue height. But in this problem nothing is mentioned about the pouring basin, means if anything which is given at this cross section, velocity, cross sectional area, flow rate, anything is given to you, then we can calculate the height of this pouring basin, but nothing is given to you, so we cannot calculate that. So we are assuming that the total height is equals to sprue only. Okay, so that that's why I'm writing over here HS. Okay, so when everything is given to you, when you will put these values of these elements, then you will get this and calculate it, you will get this value. So total time will be equals to 5.05 seconds. So the answer will be D. Okay, next is the gate question that is asked in recently gate 2020 in the second shift, I think in afternoon shift. Okay, so this is the same problem that we have seen the last one. So again we are using the same figure for that for the easy understanding. A mold cavity of 1200 cc volume has to be filled through a sprue, means this is the mold cavity and this is the volume of this. Okay, and sprue of 10 centimeter length, so the height of this sprue is 10 centimeter. Okay, feeding a horizontal runner. Cross section area at the base of the sprue is 2 centimeter square. This area is given to you, so that is we are using it here the top gate, so the area of this top gate is 2 centimeters square. Okay, consider the acceleration due to gravity is as 9.81 meter per second square. Neglecting the friction losses due to the molten metal flow, the time taken to fill the mold cavity is, okay, so that you have to find out up to the 2 decimal. So again, the same, nothing is given to you about the pouring basin, so we are using this HT as a HS only. Okay, so these are the data that is given to you, and this is the formula for that. Okay, so when you will put these values into this formula, and when you will simplify it and calculate, you will get this value. So this will be 4.28 second. Okay, so this was in the fill in the blank. Okay, so 4.28 second time required to fill this mold cavity using top gate. Okay, so the next problem is asked in GATE 2017. Okay, this is also this is a wonderful problem. Sprue is a sand mold, has a top diameter of 20 centimeter. Now something is given to you about the top cross section area of the sprue. Okay, so this diameter is 20 centimeter. Okay, and the height of this sprue is 200 mm. Okay, the velocity of the molten metal at the entry of the sprue, that is at this cross section area, because this is a sprue, from here the entry takes place of the molten material. So the velocity at this section is given to you. Okay, so this velocity is equals to 0.50 meter per second. Okay, assume acceleration due to gravity is 9 meter per second square, neglecting all the losses. If the mold is well ventilated, means there is no turbulence. Okay, and also okay, there is no turbulence. Okay, the velocity of the molten material at the bottom of the down sprue or at the gate. Okay, so at this section we have to find out the velocity. Now one concept is what we have discussed previously is here the velocity is given to you. So this velocity we usually find out with the help of like what is the velocity if we are considering this 2 section. Okay, so this V2 is equals to under root 2g HP. Okay, so this HP is the height of the pouring basin. So from this formula, now the velocity is given to you, so that HP we can calculate. Now if HP we have calculated, then HP plus HS, that is total height. So the total height is equals to will be something. So the velocity at this cross section will be equals to root 2g HT. So we can put this value and we can get this velocity. Okay, this is one concept. Another concept is, now we are going to discuss in this section is, that is we are using the Bernoulli's equation. Okay, the same equation that we have discussed, like what I have told you for this, also we have calculated from the Bernoulli's equation only. So right now I am not using direct formulas, but I am going through the Bernoulli's equation. Okay, so this is the data that is given to you. D1, I am considering this D1 section, and this is HS is the total height of this sprue, and V1 is the velocity at the starting of the sprue. So this is 0.50 meter per second. Okay, next is we are considering this Bernoulli's equation at this section 1 section, and this is 2 section. So this 2 section is itself is a bottom section, so the height H2, that is equals to 0. Pressure that we are considering at both the section is atmospheric. Okay, velocity is at this portion is given to you. H1 will be equals to the total height of this sprue equals to. Now we can calculate the velocity V2 from this equation. Okay, so when you will put like P1 equal to P2, that is atmospheric pressure. So when you will put these values into this formula or in this Bernoulli's equation, so this will be P atmospheric by rho g plus 0.50 square by 2g, that is 9.81 plus 200 mm. So this is total height, so we are converting it into the meter, so that is 0.20, that is equals to P atmospheric by rho g plus V4, no it's not V4 basically, this is V2 square by 2g plus 0. So the elevation itself is 0. Okay, so the datum level we are considering because of that only. So this pressure term will be eliminated from both the sides. So when you will calculate this term, so this will give you 0.01274 plus 0.20 equals to V2, this is V2 square by 2g. So from that we can add this value, and when you will calculate this v4 will be equals to 2.043 meter per second. Okay, so up to the 3 decimal we have to calculate. So the final answer of final velocity will be equals to 2.043 meter per second. Okay, the same velocity you can also calculate what I have told you before that. Okay, before this concept. Okay, so the next is next problem. This problem I have already discussed in one of the videos, but that is somehow related, that is really completely related with the gating system, as we are not calculating the time, but we are calculating the cross sectional area of the down sprue. So that's why I'm again I have considered this problem here as well in this video. So this problem has been asked in GATE 2007. So 200 I'm using this figure for this. This figure also was given in examination. 200 mm long down sprue. So the height of this sprue is given to you, that is 200 mm. Okay, and the cross sectional area where the pouring basin meets the down sprue. So top of the sprue. So this area is given to you, that is 650 mm square. Okay. That is at the beginning of the down sprue. Okay, that is mentioned also. A constant head of the molten metal is maintained by the pouring basin. Okay, the molten metal flow rate, that is Q, is given to you, that is 6.5 into 10 raised to power 5 mm³ per second. Okay, consider the end of down sprue to be open to atmosphere. So everywhere, it means that everywhere that we have to consider as a pressure as the atmosphere. Okay, and acceleration due to gravity, that is 10 raised to power 4 mm per second square. Okay, that is given to you. Now the area of the down sprue at its end we have to calculate. Okay, so first of all we'll apply, these are the data that is given to you. First of all we'll apply this continuities equation. So at section 2 and section 3 will be equals to A2 in V2, A2 into V2 equals to A2 into V3. So A2 is given to you, but V2 is not given. Okay, and Q is given to you, but we have to find out this A3. Okay, but V3 is not given. So V3 will be equals to root square 2g ht. Okay, so what we have discussed previously, 2g ht. So the total height will be equals to hs plus hp, but hp height is not given, but the velocity is also not given, but the area is given and the mass flow rate is given. So we can calculate this velocity from there, and the velocity will be equals to root 2g ht hp. So from that we can find out this height, and total height will be equals to hs plus hp, the same formulas, but again we are going with the Bernoulli's equations. Okay, so from here we are putting this value, that is q, that is equals to 6.5 into 10 raised to power 5 equals to A2 into V2. So this V2 will be equals to Q upon A2, because A2 is 650 mm square. So V2 will be equals to 1000 mm per second. Okay, so the next is we are applying this Bernoulli's equation at section 1 and section 2. So the section 1 is at the top of the pouring basin. Okay, where we are filling the molten material with the help of the ladle. Okay, so this is the one section, this is two section. Okay, so pressure at everywhere is atmospheric. We are considering this as a datum level because this is the bottom part. So this h2 will be equals to 0, h1 will be equals to height of this pouring basin, and the velocity, because this cross sectional area at the pouring basin, means at the initial level, is very larger than what the cross sectional area 650 mm square. So the velocity at this first section, so almost negligible or equivalent to 0. Okay, so when you will put all these value into this formula, so this will be equals to P atmospheric by rho g plus V1 square by 2g plus HP, that is total height, means H1 from the this datum level. So on upward direction we are taking, vertically upward we are taking it as a positive, so this is plus HP. Okay, equals to P atmospheric by rho g plus V2 square by 2g plus height itself is 0. Okay, so atmospheric term is cancel out, and V1 is also eliminating because it's almost 0. So HP in left hand side and V2 square by 2g in right hand side. So from here we can calculate this HP, that is V2 we have recently calculated 1000 mm per second, and 2g, that is g is also given to you, 110 raised to power 4. So from here HP will be equals to 50 mm. Okay, so now the total height will be equals to HS plus SP, that is 200 plus 50, that is 250. Now this velocity will be equals to root square 2g ht. Okay, so this ht value is 250 mm. So when you will put this, we'll get this value V3 is 2236 mm per second. Okay, now we have calculated this V3 value. So discharge we have already known, so that is equals to A3 into V3. So when we'll put this value of V3 over here, that is 2236, we'll get this value of A3. Okay, that is 290.7 mm square. So the answer is C. Okay, so in this video we are stopping up to here. Okay, so thank you so much guys.